Welcome to this Security AI Plus training module. We're jumping right into a huge topic, building and actually securing AI systems. AI is everywhere, but how do we make sure it's trustworthy? That's what we're breaking down today, the absolute essentials.
Okay, so let's get right to it with the one question every single security and risk professional needs to be asking themselves. When you're looking at a new AI system, where on earth do you even start to secure it?
And the answer might not be what you think. It's not about the last line of code or the data pipeline or the firewall around it. It's way more fundamental. You have to start with the blueprint, the core design that dictates every single thing it does. You start with how it learns.
So, that's what we're going to do. We're going to deconstruct that blueprint by looking at the two foundational paradigms of AI learning. These two ideas are the base for pretty much all modern AI. And look, if you don't get these, you really can't secure the system effectively. Simple as that.
First up, we've got machine learning, or ML. Probably a term you've heard 1,000 times. The easiest way to think about it? It's a pattern-finding engine. You don't give it a bunch of if-then rules. Nah, you just feed it a mountain of data, and it figures out the patterns all on its own. Now, on the other side of the coin, you have statistical learning. And if machine learning is the engine that finds patterns, think of statistical learning as the interpreter. It's a part of ML, sure, but it's laser-focused not just on making a prediction, but on explaining the why behind it and, this is key, quantifying the uncertainty. All right, let's dive into the first half of our blueprint and really look under the hood of this engine. Because machine learning isn't just one single thing. It's more like a family of different approaches, each with its own strengths and weaknesses.
The most common one you'll run into is called supervised learning. This is exactly what it sounds like. We're the supervisor, the teacher. We give the AI tons of examples that are already labeled, like thousands of emails clearly marked phishing or benign. The model studies them until it learns how to spot the difference itself.
Then we have unsupervised learning. This is where we take the training wheels off. We give the AI a giant messy sea of unlabeled data. Say, all the network traffic in a company, and its job is to find the weird stuff. It has to figure out on its own what looks like a normal cluster and what's a strange outlier that just doesn't belong.
And the third number of the ML family is reinforcement learning. Honestly, the best way to think about this is like training a system by having it play a video game. It takes an action, and if it's a good one, it gets a reward, a point. If it's a bad one, it gets a penalty. Over millions of tries, it learns the best possible strategy to win the game.
Okay, so why did we just walk through all that? Here's why it is absolutely crucial. Each one of these learning styles introduces its own unique risks. If your labeled data is biased, guess what? Your model will be biased. If you tell it to look for the wrong signals, attackers will exploit that. And if it overfits, meaning it just memorizes the training data, it'll be brilliant at spotting old attacks but completely blind to new ones. This tells you exactly where to focus your security efforts: the training data, the model itself, and where it makes decisions.
All right, so we've covered the engine. Now let's talk about the other half of our blueprint, the interpreter. This is the side of AI that's all about transparency, understanding, and being able to explain the why behind a decision.
So, where does this interpreter really get used? Well, it's critical for any job where quantifying your uncertainty is the whole point. We're talking about things like forecasting how many security incidents you might get next quarter, building risk models you can actually defend to an auditor, or using probability to define what normal behavior looks like.
And this, right here, is the huge security advantage of the interpreter. You can defend its decisions. When a regulator comes knocking and asks why a loan was denied or transaction was flagged, a statistical model gives you a clear, transparent answer. In highly regulated fields like finance or healthcare, that's not just a nice-to-have, it's a must-have.
So we've got the engine on one side, which is all about raw performance, and we've got the interpreter on the other, which is all about understanding and defensibility. So how do you choose the right blueprint for the security job you're trying to do?
This table just lays out that fundamental trade-off perfectly. If your main goal is raw predictive power, say for sifting through millions of events to find threats, you're probably going to lean towards the machine learning engine. But if your goal is to justify every single decision for a risk report, well, that's a job for the statistical learning interpreter.
But here's the secret. A really mature security program doesn't just pick one. It uses both, strategically. Use the right tool for the right risk. Use the interpreter where defensibility is king, and use the engine where you need massive scale. But you always use statistical methods to check the engine's work.
And that really brings us to the core message here today.
Understanding this blueprint, knowing how your AI learns, is the absolute non-negotiable first step. It tells you everything. It tells you where to put your controls, how you need to test, and what your governance program has to cover to keep these incredibly powerful systems both secure and trustworthy. So as we wrap this up, I want to leave you with this one thought. Your organization's AI is already making critical decisions, right now. The real question is, do you have the blueprint? Do you really know how it learned to make those decisions? Because if you don't know how it learns, there's no way you can truly know how to secure it.